Okay, so I want to start by by talking about the question 4 situation. Okay, so itu page 151. Itu formative exercise 5.1, right? Question number 4. Okay, so when I first saw the question, I thought it was very strange lah, sebab inside the box there are 10 balls. So ball number 1, ball number 1, ball number 2, ball number 3, ball number 4, ball number 5, ball number 6, ball number 7, ball number 8, ball number 9 and ball number 10. Tapi dia bagi tahu bahawa the probability of getting this one is 0.2 and the probability of getting this one is 0.1. So I'm like, kenapa dia bagi macam tu? You know, I was thinking at first. So then I don't remember who was it that approached me with this question first. I think it was Yong. Then when we think about it, oh mungkin dia adalah 0.2 setiap satu bah. Sebab the way the question is worded, dia macam ambiguous bah. Cara dia bercakap, the probability of selecting 1, 3 or 5 is 0.2. And the probability of selecting 2, 4, 6 or 8 is 0.1. So I thought, setiap satu, 1, 3 and 5 is 0.2. So maksudnya kebarangkalian untuk mendapat ini adalah 0.6. And then this one setiap satu 0.1, so 0.4. So I thought, oh okay lah, ngam sudahlah kan. 0.6 plus 0.4 equals to 1. But then the problem came with, kenapa ini 7, 9 dan 10 ada? Why is there a 7, 9 or 10? You know, because whenever we take into consideration the probability, we must take into consideration the whole sample space. Actually, this is maths lah, it's not maths. But we need to take a look at it in terms of the sample space. The sample space is dari 1 sampai 10 bah. So I was like, kalau sini 0.6, sini 0.4, jadi ini apa? Apa tujuan dia orang letak ini 3 bola di sini? And then it wasn't until Eva kah itu yang kasih tengok saya dia punya jalan kerja kan, that I realized that okay, there is a certain problem with this question lah. The way the question is worded, cara soalan ini ditanya is a little bit macam dia mengelirukan lah. Okay, but in the end it makes sense lah. So 0.2 is 1, 3 dan 5. Astaga. 1, 3 dan 1 atau 3 atau 5 sebab kamu hanya mengambil satu bola sahaja. So the total probability for all these three is 0.2. Manakala the total probability for all this is 0.1. Jadi maksudnya the total probability for all of this is 0.7. Okay, so when we do it in that sense, then it makes more sense lah. Okay, although betul kan? Yeah. So although macam seolah-olah this soalan kan macam membingungkan bah. Then lepas itu dia cakap kan, this process is this. Then dia cakap the random variable is memilih 1, 3 atau 5. Okay, kebarangkalian memilih 1, 3 atau 5, which is just 0.2. So then it got me asking lah, you know, and I think I was talking with Yong yesterday. Yong pun tanya, so what is the point of this? Kenapa dia mau bagi tahu ini? Kan, it's like, this is like useless information bah. Because if you know that 1, 3 or 5 is 0.2, dalam setiap kali kamu ambil lah is 0.2, maksudnya yang bukan 1, 3 or 5 is 0.8 lah bahkan. Kenapa dia mau bagi tahu ini? Why this information? Kenapa dia tanya? Okay, so for those of you who were confused by this question, I want to say that it's probably not your fault lah. The way the question is worded, dia sangat misleading. Basically, your tree diagram is just X and non-X lah. Okay, so 0.2, 0.8. And then this one is X and then not X. This one is X and not X. And then because you take 3 times, right? So X, not X, not X. X, not X, X, not X, and X, not X. Setiap satu kali itu adalah 0.2, 0.8, 0.2, 0.8, 0.2, 0.8. Okay? So I just wanted to start this class besides the all the nonsense singing to explain this just to let you know that there is this question can be worded a little bit better lah. Okay, dia punya ayat boleh lebih dicantikkan supaya dia tidak mengelirukan, because I'm asking myself, kenapa dia mau bagi ini 0.1? For what lah? Like, it's useless information. Lain lah kalau soalan itu minta 7, 9 dan 10 tahun. Then it's a slightly different situation. Okay, but what I want to do is, I want to connect this situation with our lesson today. Now, if you notice that each time dia mengambil satu bola kan, dia meletakkan bola itu balik. Okay, that means this set kejadian ini, this kejadian, okay, this set of kejadian and this set of kejadian dia tidak bergantung kepada kejadian sebelum ini, sebab dia punya kebarangkalian is always the same. Why? Because you always put the ball back. Kamu sentiasa meletakkan itu bola balik. If you remember in our previous example, we did one example of this, no, not this question. Oh no, I must have rubbed it off. Hold on. Oh, this one. Okay, this one. Okay, remember this question number 2 in our workbook. So you have 5 balls and then kamu ambil satu, tetapi kita non-replacement. So in this particular situation, this set of events, bila kita mengambil satu bola, okay, the purple set of events and the blue set of events, dia bergantung. The blue punya kebarangkalian bergantung to the purple punya kebarangkalian. Sebab kamu tidak meletakkan itu bola balik. You don't put back the ball. Okay, so this situation is what we call non-independent. Okay, or we call dependent situation lah. Okay, because kamu tengok dia punya kebarangkalian kan 3/5, then the next round the kebarangkalian berubah sudah. Sebab kamu tidak letak balik itu bola. Bilangan bola di dalam kotak itu sudah berubah. Dia bukan lagi 5 bola, dia sudah jadi 4. But in this case of our this one, we find that although there are 10 balls, every time you take one ball, you put back the ball inside the box. Okay, so we call this independent events. Independent events. Okay, and you know there is independence sebab dia punya kebarangkalian kan sentiasa sama. It's always the same. It doesn't change value. That means bila kamu ambil bola kali pertama dan kamu ambil bola kali kedua kan, dia punya kebarangkalian sama. So bilangan bola adalah sama. What happens in the second round is not affected by what happens in the first round. So we call this independent events. Okay, which brings me to what I want to teach today. Now, in probability distributions, okay, 2 days ago, I taught you that probability distributions adalah semua cerita pasal random variable. Okay, it is the story that talks about random variable, and there are 2 types of random variables. One is discrete random variables, and the other one is continuous random variables. Okay, now, when we talk about probability distributions and when we talk about random variables, we are only interested in independent events. Okay, we are only interested in independent events. That means the first time you do something, it will not affect the second time you do something. Kalau dia affected, okay, then it's a totally different story altogether. Okay, that one is higher level maths lah. We are only interested in independent events. For example, kamu melambung duit shilling. Okay, kamu lambung the first time, kamu lambung the second time kan. Dia tidak mempengaruhi. What happens the first time doesn't affect the second time. Bila kamu ada 10 biji bola dalam satu kotak, the first ball you take out, kalau kamu letak balik, then it's independent. Because the second time kamu ambil bola, dia tetap ada 10 biji bola di dalam. Okay, so The discrete random variable that we are interested in is the discrete random variable where the events are independent. Okay, and when we talk about discrete random variable, remember dia adalah bilangan kejadian yang boleh dihitung, bukan boleh diukur. Diukur is continuous. Okay, we established that in Monday's class. So today we're going to specifically talk about discrete random variables, and the name of the probability distribution is called the binomial. Okay, distribution. Okay, kenapa binomial? Okay, the word bi, okay, the word bi means two. Okay, like biannual bahkan. Biannual. I know you all are thinking of another bi word, but I'm not going to go there, okay? Biannual, okay, biannual is 2 tahun sekali. Okay, so the word bi brings to meaning two lah. So when we talk about binomial distribution, okay, when we talk about binomial distribution, we're talking about events di mana dia hanya ada dua kejadian. Seperti kita punya yang ini. Kamu mengambil nombor 1, 3 dan 5 atau kau tidak mengambil nombor 1, 3 dan 5. Okay, so in a binomial event, there are only two outcomes, which is good news for us lah, sebab kita tidak mau tree diagram kan. Cuba kau bayangkan kalau kau punya tree diagram kan sampai begini. The first time kan ada 5 events. Lepas itu 1, 2, 3, 4, 5. Then the second time 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Wah, itu boleh bikin mati kau buat tree diagram kan. So good news for us. We are only interested in binomial. Okay, two possible events. Either dia success or fail. Okay, now bila saya cakap success atau fail ini success atau fail ini bergantung kepada apa yang kamu tetapkan atau apa yang soalan tetapkan sebagai success. In this question, okay, the question 4 in this question, the success event is getting number 1, 3 or 5. Success. The not success event, okay, yang gagal, the fail event is getting number 2, 4, 6, 8, 7, 9 and 10. Itu fail. Okay, siapa yang menetapkan the success or the fail criteria? Is you or it's the question in the box lah, question in the book lah. Okay, but when we think about binomial, we need to think about two events only. What is the success event? What is the fail event? And when we think about the success event, what is the fail event? We need to think about what is the probability of success event and what is the probability of fail event. Okay. But the question, okay, the problem now is this. So far, in all your tree diagrams, paling banyak pun kamu buat 3 kali saja. Okay, except for the question number 1 in page 150, itu a bit short lah. Okay, tetapi dalam semua tree diagram yang kamu buatkan, maximum level macam seolah-olah 3 kali sajalah maximum. Okay, the maximum levels you have done is 3 times. But what if, okay, what if like this, let's say the probability, okay, of getting heads, okay, kau dapat kepala lah, okay, in a coin is 1/3. Okay, then you toss the coin, kamu lambung itu duit shilling, okay, 10 times. You know what kind of tree diagram you're going to get? If it's 10 times, first time, second, okay, sorry. So, first time, head, tail. Second time, head, tail, head, tail. Third time, head, tail, head, tail, head, tail, head, tail. You see where I'm going in this? Ini baru third level tau. Saya ada 10 kali lambungan ini. So what? Fourth time, head, tail, head, tail, head, tail, head, tail, head, tail. Kamu mau buat tree diagram sampai satu kertas mahjong pun tidak cukup muat lah itu. Okay? So we need to have a system which makes it easier for us to calculate the probability, especially where we cannot draw a tree diagram. Okay, and this is what we call the binomial distribution formula. Okay, the binomial distribution formula helps us to count the probability of what we want, okay, in a situation where the number of levels in your tree diagram, bilangan kali kamu melambung duit shilling, bilangan kali kamu mengambil bola, bilangan kali kamu membuat tembakan, okay, is more than 3 times, especially when it's more than 3 times. Because if it is less than 3 times, you can still do tree diagram. Okay, tapi macam mana kalau kamu membuat 20 tembakan? You want to draw a 20 level tree diagram? Boleh pengsan tau. Okay, so we have a shortcut method. And the shortcut method is given in the binomial distribution formula. Now, before I introduce to you the binomial distribution formula, I want you to take note of 4 very important letters, which is the letter N, the letter P, the letter Q, and the letter R. Okay, you will, if the makin dekat dengan exam kan, kamu akan dengar balik-balik ini. What is the NPQ? What is the NPQ? Okay, the NPQ is very important. So the N, okay, the N is the number of tries. Okay, number of tries. Or kalau kamu buat dalam tree diagram is the number of levels, okay, in the tree diagram. Okay, P is the probability of success. Okay, and I want you to write the success in this one. Sebab ini success ini saya kasih inverted commas. Success itu bergantung kepada apa kehendak soalan. Okay, sometimes the success mungkin adalah kegagalan untuk mendapat something. Itu dikira sebagai success. Okay, baru kita tahu. So the probability of success in one level. Okay, manakala Q is the probability of failure. Okay, in one level. One level means one level of the tree diagram lah. Okay, R is the number. Hold on, there's a word for it in this one. R is the. Oh, okay. R is the number of desired outcomes. Okay, so R ini, if you are writing notes on this, or if you are writing this on your textbook or whatever, okay, R is, I want you to star this R lah. Okay, star and then tulis somewhere there, usually is given from the question. Okay, given from the question. So let's go back to the situation in question number 4 just now, and I will show you what is the NPQ lah. Okay, so in this particular situation, okay, in this particular situation, the success, follow me closely guys, okay, I don't want to explain this too many times. Okay, in this situation, follow the question, and the question say success, success is getting 1, 3, and 5. Okay, that is the success event that you want, that the question wants. Okay, so that means fail event, failure is not getting 1, 3, and 5. Means kau tidak dapat 1, 3 atau 5. Okay, so because of that, what is my probability of success? P is the probability of success. Okay, so if you take a look at the tree diagram, this is our P. Sebab kita mendapat 1, 3 atau 5. So P is 0.2. And Q is the probability of failure in one level. Okay, which is 0.8. And that's why, itu sebabnya saya cakap tadi, sebab kita selalu menengok the success and the failure in one level, that's why the binomial distribution only can be used in a independent setting. Okay, dia tidak boleh kena pakai dalam soalan yang kita buat kemarin, this one. We cannot do binomial in this situation. Sebab satu kali kau ambil bola, kau tidak letak balik. Bilangan bola sudah berkurang. So we cannot, this one non-independent is, we are not interested in this anymore. Okay, in this chapter, we are only interested in independent events. The first time kamu buat, the kebaran kalian second time is still the same. Okay, and then in this case, in this particular question, because your tree diagram has 3 levels, so your n is 3. Okay, macam mana kamu tahu dia adalah 3? Let's say you don't draw the tree diagram now. How do you know? It's because the question say, a ball is chosen 3 times. Kamu ambil bola sebanyak 3 kali. So that is our n. Okay, so your first job, your most important job, okay, if you want to succeed in this binomial distribution, you must know how to identify the n, p, and q. Once you can identify the n, p, and q, then you can talk to me about finally starting to answer the question. Okay, R memang akan diberi dalam soalan. Well, most of the time lah. Okay, R memang akan diberi. Tetapi N, P, Q yang kamu mesti tetapkan. So think of the tree diagram every time. Tree diagram only got binomial. They only got 2 outcomes only. Success, fail. Every level got 2 levels, 2 outcomes only. So the formula for binomial distribution, okay, given in your textbook, page 155, the probability for an event, okay, or a discrete random variable equals to the number of desired outcomes that we want. Ini tidak penting, kalau saya tidak penting ini yang lebih penting. It is NPR, did I say NPR? See, pandai. NCR, okay, NCR, small letter p to the power of r, small letter q to the power of n minus r. Ini yang paling penting. Okay, small letter p, power of r, small letter q, power of n minus r. Okay, and then r will be equals to, oh no, actually ini salah ini. It should be r equals to 0, 1, 2, 3 and so on and so forth. Kenapa dia tulis r equals to 1? Silap ini. Okay, so one good news is P dan Q, the probability of P and Q, okay, is always equals to 1 because dia binomial. Okay, dia hanya ada 2. Kalau suksesnya adalah 0.4, the failure must be 0.6. If the success is 0.3, the failure is 0.7. These two, the tree diagram, when you add the probability together, they must always equal to 1. Okay, that's number 1. Okay, let's come back. Sorry, let's use this. Okay, let's use this in our question number 4 situation. Okay, so I'm going to redraw the question number 4. So in question number 4, kita dapati n adalah sama dengan 3 kali because you take the ball 3 times. Okay, please refer to page 151 again. Okay, refer to page 151 again. Actually, if you have your homework with you, it's even better because I want you to see how we use this formula to calculate the probability yang sudah kamu kira lah, yang pakai darab itu kan. Okay, so can somebody please tell me when you did your table bahkan? Okay, when you did a table, x equals to 0, 1, 2, 3. Can somebody please tell me all the probabilities in this, please? 0 is how much? Question number 4, page 151. Okay. Number 4. Sorry, don't type it out. I'm not paying attention to the chat. You have to like unmute yourself and tell me. What is the probability for 0 for question number 4?
Uh, 0.512.
0.512. Okay. 1?
0.384.
Okay. Sorry, my horrendous this one. Okay. Now 2?
0.096.
Okay, number 3.
0.008.
Okay, 0.008. So, yesterday or whenever you did this question, bahkan, you calculated this probability the manual way. Kamu buat tree diagram lah, lepas itu kamu kira lah, lepas itu kamu jumlahkan. So today we're going to learn the shortcut method, which is to use the binomial distribution formula. Okay, but binomial distribution formula, 3 first letters. Berapa kali kamu cuba? In one level, what is the probability of success? And in one level, what is the probability of failure? Ini kita sudah tetapkan. N equals to 3. Because 3 kali kamu cuba untuk mengambil bola. 1 kali kamu cuba, probability of getting 1, 3 or 5 is 0.2. That is our success. Okay, so you nyatakan lah. Our success event is getting 1, 3 and 5. Our failure event, okay, is not getting 1, 3 and 5. Okay, or getting 2, 4, 6, 8, 7, 9 and 10 lah. Okay, same thing lah. Okay, same thing. So the failure is 0.8. Okay, so in our table, ini semua ini, all this 0 and 1 and 2 and 3 is actually our R. So line R, you will get line kebarangkalian. So let's prove this. So formula Px equals to R equals to NCR P to the power R Q to the power N minus R. Okay, I can confidently tell you this formula by memory because banyak tahun sudah saya mengajar ini kan. And this is actually a very easy topic lah. Kalau kamu tanya saya, ini lagi senang. Okay, so yeah, it's a good idea for you to memorize this. So, when R equals to 0, okay, I'm going to shortcut this by writing P0. Sama lah maksudnya. Okay, when R equals to 0, P0 means kamu langsung tidak dapat 1, 3 and 5. Okay, kita mengharapkan jawapan 0.512. Okay, so it will be 3C0. Okay, our N is 3. Our R is 0. P is 0.2. 0.2 to the power of R is 0. 0.8 to the power of N minus R. 3 minus 0 will be 3. Okay. Now, the good news about this is you can satu kaligus kamu boleh tekan ini di dalam calculator. Tapi saya cadangkan, kasih kurungkan semua please. Okay, just to be safe, bracket everything. Okay, so this is how I will type it. It will be 3C0, oh sorry, bracket 3C0. Okay, like this. Oh dear. Okay, and then open another bracket, 0.2 to the power of 0. Boleh nampak kah? Okay, 0.2 to the power of 0. And then you do the same thing, 0.8 to the power of 3. Okay, when you press the equal sign, you will get the exact same answer that you got in the jadwal, 0.512. Okay, 0.512. So to say that whatever that you did on Monday is actually an introduction to this lah. Except that what you did on Monday is the long method. We do tree diagram lah, we trace the path lah, then we calculate the probability lah, then we add all together. It is the long method that you have to know for mathematics. Okay, but in additional mathematics, in AddMaths, yang kita berminat hanyalah penggunaan formula ini. You cannot use this formula in maths lah. Setahu saya lah. Anyway, they won't ask you lah. Okay, they won't ask you in maths because maths dia adalah dependent events. They will not really talk much about independent events. Okay, but this is especially useful lah. Okay, ini adalah sangat berguna, especially bila n adalah nombor yang sangat besar, seperti 10, seperti 100, seperti 20. Okay, then it's a very big headache. Okay, let's just do one more lah for you to practice how to this one. Okay, I'm going to use R equals to 2. Okay, so P2 Okay, bila R sama dengan 2, is 3C2 0.2 to the power of 2 and 0.8 to the power of 1. 3 minus 2 is 1. Okay, I want you to notice a very interesting thing. 0.2 plus 0.8, okay, dia punya jumlah mesti 1. The power, itu power yang kamu letak ini, dia punya jumlah mesti sama dengan nombor n. Okay, just something interesting and it helps us to remember this formula better. Okay, can you calculate this and make sure that you get the answer 0.096? You should be able to. Just be careful when you press the calculator. Okay, make sure you bracket everything. Hold on now. Okay? Can 0.096 boleh? Okay. Kalau tidak boleh pun kan tiada orang yang respon, jadi saya andaikan okay saja. Okay. Tak payah. Teacher lagi. Azim, so long I teach you already, you still call me teacher until now. Saya ajar kamu sampai tahun 2021 saja. Next year you're on your own. Kalau kau panggil saya teacher lagi balik. Apa baik?
Sir.
Okay, page 64, everybody. Page 64 in your workbook. Okay, page 64 in your workbook. You know why I answer questions in the workbook? Because I noticed that your class has a very interesting habit of kalau saya suruh kamu jawab soalan dalam workbook kan, terus semua orang on one side is the workbook, on the other side is the answer book. Okay, so bagus saya bincang itu soalan workbook. Kalau tidak, kamu menengok soal jawapan kan, terus kau tanya saya balik, sir, kenapa itu jawapan macam ni? Okay. Question number 1. Okay, A1. A fair coin is tossed 10 times. Okay, a fair coin is tossed 10 times. Means in your tree diagram, got 10 levels. So number 10 refers to the letter N. Find the probability that the tails appear. So your success is what? Success is mendapat tails. Okay, your failure is mendapat heads. Okay, sorry in English is heads and tails. Tetapi dalam bahasa Melayu kan is angka dan gambar ba. Angka is tails. Yeah, this is angka, nombor, and then heads is gambar. Okay, I know it's very annoying because I grew up the other way. For me, heads is the angka and then gambar is the tails. But apparently in mathematics, tails is angka. Kamu tahu bahkan apa yang saya cakap ni, angka dan gambar? Atau kau tidak pernah tengok duit shilling? Okay, never mind. So, the probability of success is 1/2 lah sebab duit shilling kan? Okay, 1/2, or I suggest that you use decimal place, 0.5. Okay, because now if you take a look, all our probability sekarang kan kebanyakannya adalah decimal place. So try not to use bracket lah. Try not to use bracket. Okay, 0.5. So Q will also be 0.5. Disebabkan P tambah Q mesti sama dengan 1. Okay, so the question say, find the probability that the tails appear exactly 4 times. Exactly 4 times means our R equals to 4. Okay, so we are finding for the probability of R equals to 4. So let's put this one in lah. 10C4. Okay, 0.5 to the power of 4, 0.5 to the power of, what is this number that I should put up here?
6.
Yeah. Actually, I wasn't planning to call anybody lah, but fine. Thank you, Efa. Okay, so this will give you the answer. Lepas kau tekan. Can you give me the answer, please? Without referring to the book.
0.2051.
Okay, 0.2051. Look at how easy it is to answer this question when you know how to use the formula. Daripada kamu melukis gambar raja pokok yang mau jadi gila macam ni, bang. Okay, I think after Monday's class kan, begitu ramai sekali orang yang tanya saya soalannya, how to do this tree diagram. Okay, so not a very good thing now. Okay, I want to go straight to number 3. Okay, number 3. Now, sometimes probability is given in percent. Okay, tapi jangan kencang, dia sama aja. So, question number 3. 80% of the Form 5 students own mobile phones. This is a lie lah, okay? I would say 99% of Form 5 students own mobile phones. In 5ST, 100% of the students own mobile phones. Okay, so anyway, 80% of the Form 5 students own mobile phones. Let's think about this. 80% means 80 over 100. Okay, atau dalam perpuluhan it will be 0.8. Okay, so this is our probability of success. So because of that, what is my probability of failure? Not owning mobile phones.
0.2.
0.2. Okay, sebab ini campur ini mesti sama dengan 1, confirm. Okay, then dia cakap in a sample of 6 Form 5 students. Ini nombor 6 ini merujuk kepada huruf N. Okay, so N equals to 6. Find the probability that all of them own mobile phones. So what is my R? Since dia cakap all, bahkan semua. Okay, so my R must also be equal to 6. Okay, can you put it inside the formula, please? This is the formula, X equals to R, NCR, P to the power R, Q to the power N minus R. Okay, substitute everything in, cuba kirakan the probability and tell me, please. Wow, there's 31 people today.
0.2621.
Okay, very good, 0.2621. So, so when this is an introduction class lah to this lah. Tomorrow we will finish. Susah sama cakap ni, saya boleh habiskan ke tidak. Okay, but I will try to finish this Saturday tomorrow. But this formula, the most important thing lah, like I said is to read the question and to identify the NPQ. If you can identify the NPQ, that's half the battle won. Okay, that's half the battle won. Sebab R dia akan berubah. R akan berubah dalam soalan. Okay, sebab kau tengok ini jadual kan, R dia akan berlainan ini, depending on what the question wants. Okay, alright, let's take a look at question B. Question B is actually the same thing that we did in the previous class, except that now we want to calculate the probability by using the formula and then make the graph. Remember the probability distribution graph that we did in the last class? Okay, this one. Okay, so we want to use the binomial distribution formula untuk buat jadual seperti ini. Okay, and then lepas itu kita buat graph. Okay, that's the most important thing. And then of course, if you want to know whether your answer is correct, remember that bila kamu jumlahkan ke semua probability inside the table, it must always equal to 1. No matter how long your table is, kalau sampai ada 10 lah, 10 garis kan, jumlah kebarangkaliannya mesti sama dengan 1. Okay, when we are doing this topic, especially this topic lah, you are going to hear this sentence many times. Okay, sampai kamu akan muak. What is the total probability? All the probability total together must be equal to what? Okay, make sure you drum it into your head. Okay, it's a very important thing. Okay, I'm just going to do one question with you and then we will call it a day lah. Let's do question number 3, page 66. Okay. And the reason why I want to do question number 3 is because nanti kau tengok lah. Okay, page 66 people in your workbook. Okay, question number 3. Sorry Okay, never mind. You know what? I'm just going to continue. Okay, so the question is, during the festive season, dalam musim perayaan, 2/3 of the t-shirts produced by a factory are red in color. Okay, so let's talk about this. 2/3. What is my success story now? My success event is red color t-shirt. So what is my failure story? My failure story is not red color t-shirt. Okay, that's the good thing about binomial, is, you're a boy, failure is you're not a boy. Success, you're a girl, failure is you're not a girl. Success is you have 1,000 subscribers in your YouTube account, failure is you don't have 1,000 subscribers in your YouTube account. Gitu. Okay, so success and failure is very easy ni. Yes and not. Itu saja. So probability of success is 2/3. Okay, kalau kamu tukar ini pergi perpuluhan, this is very complicated. Okay, you will get 0.66666666666 bahkan. Okay, so I suggest that you keep this as 2/3. Kamu masih boleh, you can still do in this one lah, but 2/3, I'm going to use 2/3 just to show you lah. So my Q will be 1/3. Okay, this one confirm. What is my N? A random, from the question, a random sample of 6 t-shirts. So my N equals to 6. Okay, so if my N equals to 6, means my table, okay, I'm going to start writing the table. Okay, my table will be 0, 1, 2, 3, 4, 5, 6, because maximum is 6. It must always start from 0. Okay, so berapa kebarangkalian yang saya mau kira di sini? I will have to count 7 kebarangkalian lah. Okay, so 0, 1, 2, 3, 4, 5, 6 ini semua adalah R yang berlainan. Okay, alright, so what I'm going to do is I'm going to assign different people to calculate this one, except that I'm just going to show you the 0 lah. Okay, so when P equals to 0, when R equals to 0, it will be 6C0, 2/3 to the power of 0, and 1/3 to the power of 6. Okay, now when you press in calculator, I want you to be careful of this. Okay, because kita tidak pakai tempat perpuluhan, kita pakai pecahan. Okay, so you should be doing it like this, 6C0. Ini biasalah, 6C0. Okay, can see? Alright, the big problem now is the 2/3. Okay, because you're doing a fraction, you need to double bracket it. So bracket 2/3, close the bracket, power of 0, close the bracket, like this. Okay, take a slow look at this. Dia ibarat apa tau, macam ni. Kamu bracket, sorry. Macam ni, 2/3 power of 0 bracket. Macam ni. Okay, do that. Because kalau kamu buat begini, 2/3 power of 0 kan, dia akan bagi kamu jawapan, dia akan bagi kamu jawapan 2, which is wrong. Okay, I think so. 2/3 power of 0. Yeah, they will give you the answer of 2, which is wrong. Okay, ini adalah salah. This is the one that we want. It should be equals to 1. Okay, so remember lah, I always say this, remember that humans are always smarter than calculators. Calculators are designed to help humans, not to take over humans. Okay, ini cerita robot sudah. Okay, so this one, you will get the answer 1/729. Okay, so I'm going to fill this in for you lah, 1/729. Kalau kamu mau buat dalam perpuluhan, I can allow you to lah, but it's very tiny lah. Okay, 1/729. So tidak apa, kita buat saja. Alright, so 1, 2, 3, 4, 5, 6. What happened to all the A's? Asha?
4/243.
Okay, 4/243, or if you want, you can do 0.016 lah, pun boleh lah. Okay, kalau 1/729, dia sangat-sangat kecil bah. 0.001, sangat-sangat kecil. Okay, pun boleh lah kalau kamu mau. Oh no, no wonder lah saya tidak anu. Okay, hold on lah. 4/243, 0.016. Okay, yang 1/729 you can do 0.001. Actually for me either way also can. Sebab the tujuan kita membuat jadual ini adalah untuk membuat graph. Okay, so the graph is actually more important. Okay, alright. Number two is the C people, right? C and D ka? Can I have Colette for this, please?
0.082.
Okay, 0.082, or the pecahan is 20/243. Okay, R equals to 3. R equals to 3 is who? The F people.
M.
No. No. 3 is M, meh? Oh, yeah, lah, you're right. Okay. Azim, since he called me teacher just now.
Okay. 160/729.
160/729, or in decimal places will be 0.219. Yeah? Okay, guys, I would suggest that kalau in your table kan, kamu letak pecahan, everything pecahan. Kalau kau letak perpuluhan, everything perpuluhan. Jangan juga kamu 1/729, then the next column kau letak 0.016. Okay, kamu menahaskan diri sendiri saja, janganlah. Okay, you standardize the reading yourself. Okay, number 4. Lepas orang M apa? Number 4 is, oh, okay, number 4 is the Karima. Let's skip number 4. Karima, you answer when you're ready. Number 5. Of course, I want Sean to answer.
64/243.
Okay, in the decimal place, it will be? Sean?
0.26.
Okay,
3.
26 what? Okay,
263.
0.263, yeah. All right. Number 6, V0. Obviously, it's V0. I'm not going to ask Yong.
64/729 kan?
Okay, yeah. The decimal place?
0.088.
Okay, 0.088. Ken? All right. Karima, are you ready?
Yeah, 80/243.
Okay, which is equivalent to?
0.329.
0.329. Okay, so if you take a look at this, if you take a look at the pattern, kita boleh agak-agak lah. Okay, remember all our binomial distribution graphs, okay, is the axis is always the same. Px equals to R against R. 0, 1, 2, 3. Astaga. Okay, 4, 5, and 6. Okay, so 0.01 is begini sajalah kali. Okay, this one a bit higher. It gets higher, 0.219. Highest is 0.329. Okay, which is somewhere about here. And then lepas itu dia akan berkurangan sedikit. Okay, like this. And then 0.088 will be very low lah. Almost the same as number 2. Okay, something like this. So your graph will be something like this. And then if you want to check whether all your answer is correct, right, you add all of this together. Okay, campurkan ke semuanya atau campurkan ke semua inilah. Make sure that it is equals to 1. Then you know that you're on the right track. Okay, and as I said before, disebabkan kita hanya melakar, we're not really drawing lah. Okay, so this one kamu letak saja dia punya nilai terus di sini. So this is 1/729. This one will be 4/243. Okay, this is 20/243, and so on and so forth. Okay, so this one we did on Monday, but now we're just going to use this formula. Okay, this formula is the one that kita mau pakai. So, Abel and Adam yang dapat jawapan tadi salah bahkan, please perbaiki ya. Okay, learn how to calculate in the calculator. Okay, learn how to calculate using a calculator. Alright. Homework for today, ya. Sorry, I'm a little bit over. Page, lepas ni kamu habis kelas ke? Atau ini ada lagi kelas lepas ni?
Habis liao.
Oh, habis liao? Oh, okay lah, I'm gonna write slowly lah. Self-exercise 5.6. There is something that we didn't discuss, but okay, fine. Number 1 to number 3, I suggest you read example 8. Okay, read example 8 to see how to answer, especially number 2 and number 3. Okay, and then on top of that, page 160, self-exercise 5.7. I only want you to do number 4. Yeah, I want you to do number 4 first. Yeah. Today's homework and tomorrow's homework we will combine. Sebab kamu, this whole subtopic is very big, so I want to combine menjadi satu. You can start doing these questions now, okay? And then tomorrow kamu just tambah lah. Tapi jangan dulu hantar di Google Classroom. Besok kita akan kasih gabung semua. Okay. All right. Thanks for your attention, everybody. I hope that you can understand what has been taught today.